This is the first in a series of videos on confidence intervals for population proportions. And first of all, let's think about what we mean by population proportions. So an example of a population proportion would be the percent of Americans who like ice cream. Now, the key is that if we think about the fact that this is a population proportion, that means it's the true number, the true percentage of Americans who like ice cream. Or let's say you ask people whether they're happy with their bank, then it would be the percent of people satisfied with their service in their bank. And what we're going to do about population proportion is we're going to try to estimate the population proportion from a sample. And the key is that the population parameter, or the population proportion, is the true value, and that's called a parameter. And the estimate is called a statistic. And that's going to be the sample proportion, right? So this is the sample proportion, and this is the population proportion. So what do we mean by confidence interval? So what we mean by confidence interval is a range of numbers. So let's say, for example, you went out and you asked people whether or not they were happy with their bank. And from that, what we'd get is we would get a number. So let's say in your survey, 23% of the people said yes. So you could say 23% or 0.23. Well, a confidence interval means it means a range of numbers of which you are pretty sure, or that you have that degree of confidence that the numbers between those two numbers. So let's say you had an interval, 21% to 25%. This is an interval. And let's say, we're going to talk about why we can say this, but let's say you can be sure, you can be 90% sure that P, that is the true population proportion, is between 0.21 and 0.25. That's what we mean by a confidence interval. And the way that we estimate P is with P hat. And P hat is simply you take a sample, and the total number in the sample is on the bottom, and the number of respondents who answered yes is in the top. And when we estimate P with P hat, we can think about the sampling distribution of P hat. And we can talk about shape, center, and spread. The shape of it is under certain conditions, the estimator, P hat, will be normally distributed. The center will be that the average, so you can think about mu P hat, if you can call it that, will equal to P. Or another way to say it is that the expected value of P hat is equal to P. This simply means that it's unbiased, right? That's the key. It's unbiased. And the spread, now think about the spread. The spread talks about in any given sample, how different could the results be from sample to sample, right? So if you think about two distributions, here's a distribution with a wide spread, and here's a distribution with a narrow spread. The spread is measured by the standard deviation, and we talk about the spread of the estimator P hat. What we mean is that sigma P hat will equal to the square root of P hat, of P times 1 minus P. And that's what we mean by that. So in a second, we'll look at the second video.